Okay, so since we are not going to get to have that review in class, I thought, hey, why not go ahead and do it this way? Because I know that you guys all love to hear my voice, right? Okay, just kidding. All right, so 2.5, we've got a question from 1 through 8, one from 9 through 21. I cut two of those out, one from 25 to 32, and one from 33 to 38. So looking at 1 through 8, these are use the rational zero theorem to list all possible rational zeros for each given function. So if I look at number 4, for example, so then, I guess I should have picked a pen that worked, huh? All right, this setup right here, it's a little bit messy. I apologize. Okay, so we've got f of x equals 2x to the fourth plus 3x cubed minus 11x squared minus 9x plus 15. Okay, so to list the possible rational zeros, we take the factors of the constant over the factors of the leading term. So then your possible zeros are going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, all over plus or minus 1, plus or minus 2. Excuse me. And then we have to do each of the numerator values over the first denominator, and then each of the numerator values over the second denominator. So then that is going to give us a total of plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1 half, plus or minus 3 halves, plus or minus 5 halves, and plus or minus 15 over 2. So these would be the possible zeros. Okay. All right, so now looking at the 9 through 21 section, this is where you are supposed to list all of the possible rational zeros, and then you are going to use synthetic division to test one of those to get it down to a quadratic, and then we're going to solve it for the other two. Now, quick reminder, we are not testing all of those zeros until we find an actual one. We are using the graphing calculator to help us find one. So that's really what step B is. So looking at, let's do problem 13. So I've got f of x equals x cubed plus 4x squared minus 3x minus 6. Okay, and first thing that we're going to do is list all the possible zeros. So then that's going to be factors of 6 over factors of 1. Right. And so everything over 1 is just what's in the numerator. All right, and then for part B, we are bringing in graphing tool, and we are going to enter in that equation. Let's see if I can get this where it's not. There we go. I hope. So we've got x cubed plus 4x squared minus 3x minus 6. I'm going to graph it. And this one, it's going between 1 and 2. It looks like it's going at -1. And I do have 3. Nope, I don't have 3 over 2. That was the last one. Okay, so the only possible options I have are 1, 2, 3, and 6. So I'm going to try -1. And remember, you can go to second graph to access the table. And then this is going to allow you to find where the y equals 0, and that is in fact at -1. So we are going to test -1, and we're using synthetic division. So that's going to be 1, 4, negative 3, negative 6. We bring down the 1. Negative 1 times 1 is negative 1. 4 minus 1 is 3. Negative 1 times 3 is negative 3. Negative 3 and negative 3 is negative 6. Negative 1 times negative 6 is 6. Negative 6 plus 6 is 0. So now I have a quadratic term, a linear term, and a constant. So now we are going to use the quadratic formula to find the other remaining zeros. So then I have x equals negative 3 plus or minus 3 squared minus 4 times 1 times negative 6 all over 2 times 1. So then this is going to give me negative 3 plus or minus 9 plus 24 all over 2. So that's going to be negative 3 plus or minus the square root of 33 over 2. Okay, so then, I didn't realize that went off the screen. Okay, so then that means I have 2 zeros here, and I also have a 0 at negative 1. That is what I'm expecting to see from you guys. So listing your possible zeros, doing synthetic division, using the graphing calculator to find one of the zeros, and then taking whatever this 0 is and doing the synthetic division to break it down to the quadratics, and then using the quadratic formula to find the remaining 2. Okay? All right. Now looking at, whoops, I folded it. Now looking at 25 to 32, we've got find an nth degree polynomial with real coefficients satisfying the given conditions. If you're using a graphing utility, use it to graph the function and verify the real zeros and the given values. Okay, so let's do 25. So for number 25, we're told that this is a third degree polynomial. So I'm going to have f of x equals a sub n, x minus something times x minus something, because I have 1, 2, 3. All right, and now I'm told that I have a 0 at 1, so that's going to be x minus 1, and I have a 0 at 5i. So I'm going to have 1 at 5i and the other one at negative 5i, because 5i and negative 5i come in pairs. If one is there, then we know we have the other one as well. Okay, so then this is minus negative makes that positive. My suggestion is always to work with the messier ones first because they do clean up nicely. So then we have a sub n times x minus 1 times x squared plus 5ix minus 5ix minus 25i squared. I know that I squared is the same as negative 1, and 5ix minus 5ix cancels out. So then I have x minus 1 times x squared minus 25 times negative 1, so that's going to be plus 25. So we have got x squared plus 25. Now I distribute everything, leaving that a sub n out front. I have x cubed minus x squared, and then I've got negative x squared. Wait, sorry. So I've got x times x squared is x cubed, and then negative 1 times x squared is negative x squared. X times 25 is 25x, and negative 1 times 25 is negative 25. There we go. All right, and so then f of negative 1, okay, so this is the first step of it, and this is going to be broken into 2 different parts. So you get credit for doing this part, which hopefully you can all do this. And then for the second part, you're actually going to find the, with the real coefficients, okay? So f of negative 1 equals negative 104. So that means I am substituting in negative 104 for this f of x, and I am substituting in -1 for x. Whoops. So then we've got -104 equals a sub n. We've got -1 minus 1 minus 25 minus 25. So then we've got -104 equals a sub n. This is going to give me -52. I'm solving this for a sub n, so I need to divide both sides by -52. And in this case, a sub n is 2. And if a sub n is 2, then I need to take this and plug it back in here to get that polynomial. So then f of x is going to be equal to 2x cubed minus 2x squared plus 50x minus 50. Okay? All right, now looking at 33 to 38, this one is using Descartes' rule of signs to determine the possible numbers of positive and negative real zeros for each given function. Okay, so let's take a look at number 35. Okay. So looking at 35, we've got f of x equals 5x cubed minus 3x squared plus 3x minus 1. All right, so then for the positive, we just analyze what we've got. And I've got a positive to a negative, so that's 1, 2, 3 sign changes. So there are 3 sign changes, which means there are either possible positive zeros, there are either 3, or I subtract 2 from there until I get down to 1 or 0, so that would be 3 or 1. Okay, then for the negative, I substitute in a negative x for the f and evaluate that. So 5 times negative x cubed minus 3 times negative x squared plus 3 times negative x minus 1. So I've got negative 5x cubed minus 3x squared minus 3x minus 1. There are 0 sign changes. So then I would have 0 possible negative real roots. Okay, that's all we're doing for the Descartes rule. Okay, now let's take a look at 2.7. Nope, sorry, 2.6, my bad. Okay, so 1 through 8, we are going, instead of having 2, we're only going to have 1. And so looking at number 4, finding the domain is going to mean that you have to just look at your denominator and any place where you would have restrictions. So x is 2 and x plus 6 is 0, so x is negative 6. In both of these places, your function would be undefined. So therefore the domain, 1 hump, not 2, there it is, domain. So that's going to be negative infinity to negative 6 and negative 6 to 2 and then 2 to infinity. Okay, 21 to 36, sorry, wrong page. 21 to 36, we've got 1 coming from here, and this is finding the vertical asymptotes, if any, and also any corresponding holes. So I know you guys did the evens, so let me take a look at number 33. So for 33, I have r of x equals x plus 7, x minus 3, all over x plus 7. Okay, so for this one, this is going to create a hole, and this hole is going to be at x plus 7 equals 0, or x equals -7. And there are going to be two from this section. So I would bet that one of these is probably going to have a hole and the other one's going to have a vertical asymptote at the very least. So looking at 25, we have x over x plus 4. Okay, so this is going to create a hole. This one is going to create a vertical asymptote. So then I have a vertical asymptote at x plus 4 equals 0, or x is -4, and we have a hole at x equals 0, which is just x equals 0. All right, horizontal asymptote. So looking at the horizontal asymptote, let's see. I cannot recall which ones you've done. I feel like you've done this one, or this one, so maybe I did the wrong ones. Okay, looking at number 40, in order to determine if it has a horizontal asymptote, we have to compare the degrees of the leading terms. Both of these are a degree 2, so since they have the same degree, their horizontal asymptote is y equals the ratio of the leading terms. So 15 over 3, which is just 5. If it is bigger up top, then there is going to be no horizontal asymptote. And then if it is bigger down below, this one is going to have a horizontal asymptote at y equals 0. Okay, so bigger down below, y equals 0. Same ratio. Bigger above, none. All right, that is 37 to 44. There's two of those from this section. And now 45 to 56. And for this one, you are going to be using a graphing calculator. And so looking at number 56, for example, we've got 1 divided by, and now you're going to want to do open parentheses, x minus 3 close squared, and then plus 2. Okay, so now looking at this, this is telling me that my graph shifted 3 to the right, and this is telling me it shifted 2 up. So if I'm graphing this, here's my axis. I'm going to go over 3 to the right to get the vertical asymptote, and I'm going to go up 2 to get the horizontal asymptote, and then I can easily draw my 2 pieces of this function. Okay? So that is the expectation. 1 over x plus 1, you know that this is going up 1. So then your horizontal asymptote is going through y equals 1, and you're going to have a function that looks similar to this. Okay? Okay, I'm going to go ahead and stop this one.